All right, I think we will get started. Welcome everybody for today's webinar. My name is Ruby Karat and I'm the Partnerships Manager at iWave. And today's webinar is a joint effort with our technology partner Xilinx and Disti, and it is being titled 3D Visualization and HMI Software on Zynq UltraScale plus MPSoC. So, a few housekeeping items before we get started. The webinar is scheduled for 1 hour, including the Q&A. All dial-in participants are muted to enable the speakers to present without interruption. Recording of the webinar and slides will be made available to all attendees in 2 days. Should you have any issues, please use the chat button and let us know. Presenting today is Rohit Gopalakrishna, Country Manager Xilinx, Tawfiq Ahmed, who's from iWave Product Marketing, and Christopher from Disti, who is the VP UX UI Technology. So what you see here is the agenda for today's session. So we start with a little understanding of the Xilinx UltraScale plus MPSoC in industrial and automotive HMI, a quick look into iWave's portfolio of Xilinx MPSoC platforms and how to get started with Zynq UltraScale plus MPSoC, followed by a deep dive into DiSTI GL Studio of HMI and UI UX software. And then we have the Q&A session. So on right hand side of your screen, there should be a chat box. Feel free to post any question at any time during the webinar. We will try to answer as much as possible. If we cannot, we will reach out to you later. So without further ado, sit back and enjoy everybody. I will pass it over to Rohit. The floor is all yours, Rohit.
So to give you a brief introduction of iWave, so in terms of who iWave is, maybe we'll just talk about iWave, the MPSoC portfolio and the video codec, and then maybe Rohit can give a much deeper introduction about Xilinx. So my name is Tawfiq and I head the marketing team at iWave Systems. And who are we at iWave? So iWave was established in the year 1999 purely as an embedded systems engineering services company, and over the years have transitioned into a product engineering organization. And we have been a Xilinx certified partner since 2005 and have built the complete FPGA based design, development, and solution expertise over the last 15 years. And I've helped companies across the globe in their product development journeys and enabling them to get to speed at a much rapid pace with reduced development complexity and risk. And iWave, headquartered in Bangalore, the complete engineering team in Bangalore, and we help companies across the globe with a strong ecosystem of manufacturing in Japan and Taiwan. So we take the responsibility of design, development, and manufacturing and complete product longevity over the years. Now looking at the MPSoC platform, so the Zynq UltraScale plus MPSoC provides the 64-bit processor scalability while combining real-time control with soft and hard engines for graphics, video, waveform, and packet processing. And these adaptive SoCs complement the decade-long availability of soft-core CPUs and other soft IP for building systems on FPGA-based solutions. And with this extended memory subsystem, there's a provision for increased bandwidth and added support for DDR4 and other memory technologies. The MPSoC includes an all-new graphics system for 2D and 3D rendering that you would commonly need for your GUI and displays, which we will be touching upon in the next few slides. The peripherals are extended through the hardening of a transceiver block in the processing system itself. And this enables interfaces like USB 3.0, PCIe Gen 2, and a native display port. And with this MPSoC built with many elements which you naturally need, you will not need all of them. So the power management provision is enhanced and increased granularly to turn on blocks as and when required. And this emerging adoption of adaptive SoC with the MPSoC includes medical imaging, remote diagnostics, high precision medical measurement equipment, and various video analytics or avionics solutions which require high speed design and high performance embedded computing platforms. Now, looking at the various variants available in the MPSoC family. So the CZ consists of a dual-core ARM Cortex-A53 processor, which is suitable for industrial motor control and sensor fusion applications. The EG consists of a quad-core A53 core and a Mali 400 MP2 GPU, and this is more suited for wired and wireless infra, data center, defense, and aerospace applications. The EV features the same application and graphics processor as the EG device, but also features the H.264, H.265 video codec, making it suitable for multimedia, automotive, and surveillance applications. So now looking at the various building blocks on the MPSoC. So it consists of a real-time control, processors for real-time control, processors to run your application software, and the complete FPGA fabric to accelerate or interface anything you want. But it is often forgotten that the MPSoC also has an integrated GPU which is capable of rendering your HMI. So the GPU which is renders your HMI helps you save power and other resources and various other display-based features. So the ARM Mali GPU is an OpenGL ES 2.0 capable GPU built for ARM SoCs. And this Mali GPU is well suited for video acceleration with significant power and performance benefits. The ARM Mali core is a pure 3D engine that renders graphics into memory and passes the rendered image to another core, making it able to handle the display. Now looking into the video codec unit. The video codec unit is an integrated block in the programmable logic of the MPSoC. So this makes it no direct connection to the programming processing system, which contains the encoder and the decoder interface. So here what I've highlighted is the codec block itself, but also the hardened memory controller within the processor system. So being a dedicated building block in the logic, it is cost and power optimized for the high performance compression standards. While supporting up to 4K 60 frames per second operation, the embedded firmware automatically clock gates internal elements to actively manage power consumption when working on lower rate streams. So let me take the example of a typical teleconferencing application. So where you first capture the image, place it onto memory, and after some bit of pre-processing, the memory would then be read by the encoder, the stream encoded and returned back to the memory, and will finally under software control and typically then leveraging the A53 cores, it will be transmitted to Ethernet. So similarly on the return path, it would be the data would be received through Ethernet, de-encapsulating the packets and placing in memory. The decoder would then be responsible for reading the encoded bit stream from memory, decoding it, and passing it back to the display, potentially leveraging the GPU to realize as a graphical overlay. So now in today's world, there's a large requirement for high-speed video transmission, be it the live sports broadcasting, video conferencing. There is a huge requirement for video transfer at real time. So the logic core H.265, H.264, H.265 video codec unit core, this supports multi-standard video encoding and decoding, including the support for the high efficiency video coding and advanced video coding standards such as the H.264. There is support for simultaneous encoding and decoding of up to 32 streams with a maximum aggregated bandwidth of 4K at 60 frames per second. The video codec accurately encodes and decodes the H.264 and the H.265 standards with the transcode ability of the EV variant, helping in reduction of bandwidth with no loss in quality. And this using only the hardened engines and peripherals of the EV devices, the integrated programmable logic is available for product differentiation, which can be made use for best optimal use of your video processing algorithms or your filter overlays and custom interfaces. And the VCU supports 4 latency modes: the normal latency, reduced latency, low latency, and the Xilinx low latency. And these low latencies can be accredited to the simultaneous transcoding capability of the integrated VCU. Now, looking at this, the maximum number of streams should be equivalent to a 4K frames per 60, 4K resolution at 60 frames per second bandwidth. So what you see here is the various combinations of your input streams with different resolutions at different frames per second. So this is completely supported by the ZU EV variants. And now looking at why MPSoC for the HMI based applications. So as I touched upon the GPU and the video codec unit, so these along with the complete heterogeneous processing power of the MPSoC with the capability of multiple processing engines, the Xilinx MPSoC supports extensive catalog of the standard peripherals and industrial Ethernet standards and offers flexible IOs with the capability to build interfaces required for such HMI applications. And a huge ecosystem of plug-and-play IP cores for your FPGA-based MPSoC helps in easy development of your HMI solution. Now, looking at the iWave portfolio of Zynq UltraScale. So, iWave has been a global leader in the system on modules category. And together with Xilinx, we have created our suite of portfolio of system on modules. So, the one you see on the left-hand side is a powerful system on module integrated with the ZU 11, 17, and 19, which is the largest FPGA in the UltraScale plus MPSoC family. Available in -1, -2, and -3 speed grades. The module is integrated with an extensive set of peripherals such as the PCIe, USB 3.0, SATA, or the gigabit Ethernet. And with the support for up to 32 GTH and 16 GTY transceivers, the system on module is built to power high performance and high speed demanding applications. Now on the right hand side is your system on module, which is powered by the ZU 7, 5, and 4 MPSoC with compatibility across the CG, EG, and EV variants. And this system on module supports the high speed connectivity options such as PCIe, USB 3.0, gigabit Ethernet with additional high-speed GTH and GTY transceivers. And this system on module is available in commercial and industrial grades and helps customers speed their development cycles. And looking at now, what is the advantage of this system on module and what is the scalability it provides? So the SOM approach for the FPGA SoC further allows greater scalability for the end application in terms of logic density, FPGA IOs, and number of transceiver lanes. So for example, a well-designed carrier board architecture can cover system IO ports for multiple end products ranging from the ZU4 with 192K logic cells all the way to ZU19 with 1.1 million logic cells. So this SOM approach allows you to migrate to new generation SoC solution without changing the product architecture or mechanical architecture. And the complete power circuit design with the associated power sequencing, the power density, the form factor, the thermal constraints are all taken care of by iWave, which helps you focus on your key system development. And iWave takes the complete responsibility for the product longevity and the supply chain management, which in today's present scenario is a key concern for companies across the globe. And the system on modules undergo EMC compliance test and several rugged tests such as thermal cycling, aging, and stress, and allows you to build your product with ease onto our system on modules with assured performance. Now, there is also a single board computer or an embedded platform available off the shelf, which enables customers to build a user interface to their products with a 3D visualization solution, speeding their time to market. So this has been integrated with the GL Studio, which Chris will touch upon in the next few slides. So this off-the-shelf solution is integrated with the ZU4 5 MPSoC and is built with feature-rich interfaces such as the display port, the USB 2.0, 3.0, or the 2 gigabit Ethernet interfaces. And with the provision to connect multiple wireless connectivity options, this powerful solution can be built to power your HMI applications. And with the provision for board-to-board connectors with 120 FPGA IOs for expansion, this solution can be customized to scale up to your required feature requirement. And now looking at different types of end applications or requirements. So there are different types of operating systems required dependent on the functionality, the features, the corresponding real-time operating required. So in complementing our portfolio of system on modules, we also offer the complete software updates of Linux, bare metal, VxWorks, and Ubuntu, complementing our complete system on MPSoC based system on modules, single board computers, or the solutions. So how do you get started with the UltraScale plus MPSoC? So iWave has made available a range of development kits available with various adaptive MPSoCs ranging from the ZU4 all the way to the ZU19. And these kits are integrated with they come with a ready SDK which are integrated with various hard blocks such as the 4K HDMI, input and output, 12G SDI, 100G Ethernet, or your high-speed MIPI CSI cameras. So which helps you get started with your development at a rapid pace. And also available with the expansion cards through the FMC and the FMC Plus connectors. The development kit enables customers to access the high-speed interfaces. Through this extensive feature-rich, ready-to-use development kits, customers are able to build quick prototypes to evaluate product market fit and evaluate performance across the complete range of MPSoC ranging from ZU2 to the ZU19. And these development kits are available for immediate shipping from both Mouser and DigiKey, which can help you get started within a day's time on the evaluation of the Xilinx MPSoC for your HMI solution. So that's it from iWave. I will now hand it over to Chris from DiSTI, who can take you through GL Studio and the solution. Over to you, Chris.
Okay, thank you very much. Quick radio check. Can you hear me okay? Hello? Yes, okay, perfect. All right, well, my name's Chris Giordano. I'm the Vice President of UX UI Technology here at DiSTI. I'm going to give you a real quick background on the company, but then we're going to jump right into the HMI technology and how it applies to both Xilinx and iWave. So real quick, the DiSTI Corporation, we're centered here in Orlando, Florida. We've been around for since 1994. Very focused on HMI services and especially commercial off-the-shelf tools. We've got numerous ongoing multi-million-dollar programs. Currently, over 700 companies around the world use GLStudio. So it's very well adopted in a number of different markets. So you'll notice from some of our select customers that we do a lot of work in aerospace, in defense, but also in automotive, medical, rail, industrial, pretty much anywhere where you see visual human-machine interfaces, any GUI applications, either safety critical or standard, you will see our GLStudio development tools. As a few examples of those, we've got some fairly large adoptions between Boeing, Boom, and NASA. For spacecraft, for aircraft avionics. Garmin has also adopted us for automotive. We were standardized on for 9 years at Jaguar Land Rover for displays there. Hyundai and Kia Motors, also Fendt is a great example for agriculture and industrial as well. So let's go ahead and take a quick look at the technology behind this. So it's the GLStudio HMI tool itself. And GLStudio works exactly the same, independent of which market you end up implementing it in. Could be a simulation and training or rapid prototyping. Could be out into safety critical embedded avionics or other safety critical visual applications, including in automotive, industrial, medical, agricultural. So the way that GLStudio works, it allows you to drag and drop graphical assets. You can create your own custom behaviors. And the development platform itself is cross-platform. So you can develop on Windows, Linux, and a Mac. And you can actually cross-develop and cross-deploy. So once you have your design to the look and feel and the behaviors that you want, you then select from one of the different code generators that we have. One of them is for desktop. Let's see. Good question, Suresh. I'll get to that one at the very end. This is on HMI platform supporting AI. Remind me of that in a few more slides when we're all done. So the three code generators we have, one is for desktop, which allows you to create standalone applications, WebGL, WebAssembly. It's great for prototyping, rapid prototyping. And the same design that you would be using on your desktop application can then be used for a standard embedded application or for Android, right? And that is one of the code generators that we have for GLStudio ES for embedded systems. And then we have a third code generator and corresponding runtime for safety critical applications as well. So let's jump down a little bit deeper into taking a look at what that workflow might look like. So GLStudio was actually born as the programmer's HMI tool. And as the programmer's HMI tool, we do not lock you out from doing anything that you want to do in the tool. You can program your own behaviors. You can derive from any of our behaviors and create your own custom versions of it. You can override any of our behaviors and create your own custom behaviors, importers, exporters, object types. It's an extremely flexible system. However, as we start to move into the UX and UI design world, a lot of times that level of flexibility is not really required. And so we actually have a UI design framework that allows you to drag and drop applications or drag and drop your graphics and then visually attach behaviors that exist. And so the GLStudio HMI tool then becomes the conduit between your design team, your UX team, and your implementation engineers. So it is a tool that you can use from concept to prototype all the way into production on the embedded hardware. So let's take a look at what that workflow might look like. So on the left-hand side, the blue block here, we've got our development platform. On the right-hand side, the blue block here, we've got our embedded target platform with Xilinx and iWave, for example. So on the left side, we may start with Photoshop files, SVG files, 3D Studio Max 3D files. We may even have things like Figma for a UX design platform. And you can drag and drop all of that content into the GLStudio editor, and GLStudio will polygonize all of that with you or for you and give you the ability to visually attach behaviors. From there, we're generating C++ code and compiling that against our runtime library to run on your desktop. Now, the nice thing is, yes, Andre, good question. There is a free trial of GLStudio. If you go to disti.com, we can get you set up with that. And we can also get you set up with access to our engineers if you have any questions as well. So if we look at our workflow here on the prototyping side for desktop, the same code that's being generated for your desktop application, you can use either our ES or SC code generator and then compile that to a different runtime library that is specific to your target system. So in this case, we're running Xilinx with iWave, and We are fully cross-platform compatible to any operating system or RTOS. All we really require there is that you have a C++ compiler and support for OpenGL. So essentially, the exact same application you create for prototyping is what runs out on your target system. There is no need to make changes or to update that as well. So a lot of times we get the question on functional safety. Now, first of all, the Disti Corporation is ISO 9001, 2015 certified for many, many years. The safety critical code generator that we have was actually designed for functional safety in avionics. So for those of you who are in the aerospace world, you'll be familiar with the DO178C certification. That goes up to level A, which is their highest level, and then a DO330 tool qualification for TQL1. So those are the highest levels of certification for functional safety in aerospace for avionics. Now, the key there is that those same runtime libraries, because of the level of rigor with the FAA, are able to go through FDA certification, automotive certification, rail, industrial. And so we've been through several of these. We're now being used in medical devices out in the field that have been certified by FDA and CE approval. We were the first company to have our ASIL D certification for ISO 26262. We're also operating in rail, agriculture, in nuclear as well, so NQA1. So the GL Studio runtime library is extraordinarily reliable and very performant for your runtime application. So the question then is, how does this apply with Xilinx and with iWave? So if we come to the next slide here, you'll see we've actually put in place a great demonstration. It's we call it our quad demo. The link is there to the YouTube channel. Now with the quad demo, we're showing a medical application, an industrial controls application, automotive infotainment, and an automotive cluster. Now, within that demo, all four of these demonstrations are running at the same time, and you actually have really, really great performance. This is all running out on the new Creo board. You can download this from the Xilinx App Store, try it out yourself, but you can also go and have a quick look at the web on our YouTube channel as well. So the real big benefit that you get from working with partnerships like what we have between iWave and Xilinx is really about all of this pre-configured architecture. You don't have to do this level of configuration on your own. We've done the integration. We've tested it. We know that it is a very flexible, high performance, and reliable solution. And that's really the big benefit that we're able to bring to market together as part of this relationship. Now, we are part of the ARM functional safety partnership, and we've been partnered with Xilinx now for many, many years, as well as iWave. And so I'm going to slide over to our last slide here. So real quickly in the news, some of the latest things, we've gotten some major adoptions by Hyundai and Kia Motor Group for 3D infotainment, for heads-up displays. There's a few links in here that you can go to have a look. Garmin has adopted us for their IVI integrated cluster that will actually be showing at CES shortly. And wait, one last. The Air Force has awarded Disti with several basic order agreements. They're called BOAs, for 5-year agreements. I've put a few links to some of our more popular white papers in there for you for autonomous vehicle safety, as well as augmented reality heads-up displays. And with that, I will hand it back to Ruby. Thank you.
If you can take over the question, please. Hari, I think Hemant here is asking whether can we use GL Studio for iWave Rainbow G33D Smart Board also. Maybe Sheikh sir or Emmanuel sir?
So I can take that one if you like, Ruby. Yes, we do. The key for GL Studio support is that we have one hard requirement, is that the boards support OpenGL. So with that, you need some sort of accelerated OpenGL. A GPU would be perfect. Now, if you're working with a microcontroller unit, we actually have a version of GL Studio we call GL Studio Micro. And we can port that to any proprietary customized HMI API. But from our standpoint, as long as the iWave Rainbow G33D that Hemant was asking about, as long as there is OpenGL support, we can support that. There was actually another question a little earlier about supporting AI. Let me see if I can see that one real quick while Rohit gets that in motion. So it looks like it's from Sheikh. Is also supports AI from Suresh. There it is. So with HMI platforms supporting AI, the real key there is to create that interface that you're looking for, right? And so within GL Studio, you've got the ability to create your own API. So you can create your own, what we call class properties. So a property will give you a set and a get method and a data variable. And with that, you will need to have an AI system that can expose its API. Once that API is exposed, GL Studio can connect to it, no problem. I hope that answers your question, Suresh. Jazinder, you are asking if there is some getting started documentation for GL Studio. The answer there is yes. If you go out to disti.com, there is actually a download option on the GL Studio tab, and you can download and have a quick look at GL Studio and all of the user's manual as well will be installed there for you, and then you'll have access to taking a quick look at how that works, and some of the links that I just sent in the videos, you'll see real briefly how some of that works as well. I hope that helps. Good question, Suresh. So the question is, you're welcome. The question is, how does a graphics tool accommodate functional safety? So I guess that what's really behind that question is, what's the difference between a standard embedded application and a functional safety embedded application? So if you'll notice in one of my slides, I think it was 7, where we were talking about the target porting, where you could use either the GL Studio ES code generator and runtime library or the GL Studio SC code generator and runtime library. Now, the difference there is that in safety critical, the way that we developed the code generator and the runtime library was developed to functional safety standards. So there are things that are removed from that library that are disallowed by functional safety standards means. And so really what it's about is removing entire classes of potential defects from ever being able to happen in your runtime library or in your generated code from the beginning. So there's differences in what the API looks like between standard embedded and safety critical. But that is by nature of how safety critical works, certain things that are disallowed from being able to happen in the safety critical environment. Hope that helps, Suresh.
you so much, Chris, for answering all those questions. We've been trying to get Rohit on stage for a while now. He is here. He's able to hear all of us, but somehow his mic doesn't seem to be working, or there seems to be some technical issue which we are unable to figure out. If you people have any more questions, please feel free to put your questions here. All right, I can see there's one more question to Chris from Hubert. Is there also an IEC 61508 certification? Chris, if you could take up this, please.
Sure. Yeah. We have not been through the 61508 yet ourselves, but some of our customers have. So it is possible to go through it on your own, or we could do that as well. Oh, it looks like Don just sent an upgraded link to the different white papers that are there. So back to the 61508 question. So the 61508 is really the parent to things like the ISO 26262, which we have been through, to ASIL-D. So if you're wanting to go through 61508, I encourage you to reach out to us, Herbert, and we'll be happy to have the discussion with you.
Hello.
You're most welcome. Yes, I think we heard you. Is that Rohit?
Yeah. Can you hear me now?
Yes, we can.
Oh my God. Okay. Thank you so much. Thank you so much, Ruby, iWave team, and Chris, for patience. I have been trying to connect from last 45 minutes. I don't know why I was not able to. I guess we still have some time, so I'm going to go ahead and give a few slides from Xilinx to the team. First of all, I apologize for having some issues on my microphone. Can you still hear me okay? Hello? All right. Okay. Thank you so much. Ruby, if you can go to the next slide, please. All right. I'm going to give a very quick introduction to Xilinx. I think most of you might already be aware of Xilinx. This should have been the introductory slide, but because of the microphone issue, I had to present this last. Xilinx is a very large semiconductor company. We're currently 3.15 billion FY21. We're more than 5,000 employees worldwide with 60,000 plus customers that we serve globally. We have a history of innovation, and we've also had a very strong patent portfolio within Xilinx, which shows up in the innovations that we have been doing for several years now.
Yeah, sorry, I think it is specific to my name, I think so. That's the reason you are not able to join. Now, it closed down, like it shut down for me. I think you can join using whatever link you got. That's the reason.
Sheikh, can you go on mute, please?
Now, Rohit, anyway.
Okay. Thanks, Sheikh. Can somebody still confirm? I just want to know that you are able to hear me. I'm sorry for that. Thank you. Okay. All right. Thank you. All right. Can you go to the next slide, please? So Xilinx is quite diversified in terms of the markets that we serve. Our primary market has been the industrial, automotive, and defense and aerospace. But over the period of time, we have also diversified into wired and wireless. We are very much there in the 5G domain right now. But we are also recently we have also started working on the data center. Since last 3 years, Xilinx has strongly entered the data center acceleration market with our new product portfolio called Alveo. Right. So the balanced mix of business from different markets actually gives us the ability to stay strong in terms of different situations in the market, and generate enough cash flow to stay afloat and ensure that we are generating the right level of innovation for our customers. Next slide, please. Okay. So Xilinx has been in the industry for more than 37 years now. We started in 1984. So you can see there the 1984 is the first chip that we introduced, which was the world's first FPGA. Xilinx is the inventor of FPGA. a little bit more than 10 years later, we started with our first high capacity Vertex device, which was at that point an architectural breakthrough. It was fundamentally still an FPGA. We did not have any processing core inside the chip. In 2001, we introduced our first FPGA which has integrated SerDes and also a power PC, right? This was called the Vertex 2 Pro. In 2001, this was a very famous FPGA, and a lot of designs were done based on this. But still, it did not have a full system on support to make a processor usable by many applications. So several years later, in 2012, that is when we had a real breakthrough with the introduction of first 3D FPGA, which is what we call a Zynq family. Zynq is a full SoC with real application processors and complete subsystem of caches, memory controller, peripherals, DSP blocks, SerDes, and most importantly, the ARM processor. In 2017, we launched our MPSoC. Tawfiq covered this product in detail in his slides. This is our second generation Zynq SoC, which is something that we also call as the heterogeneous multi-processing SoC, which added several other engines. It added a A53 core, R5, and a Mali GPU, which basically helps in optimizing processing requirements for complex systems. In 2018, we introduced Alveo. As I mentioned in the previous slide, we entered into the data center market with Alveo product line. With the Alveo, basically the focus was on FPGA acceleration in the data center. And in 2019, we introduced our 7nm family called ACAP, which are not really FPGAs. It's not an evolution of Zynq SoC. ACAP is from scratch a heterogeneous, very flexible meta platform on which you can overlay multiple domain-specific architecture and kernels. ACAP still have functions of multi-core general purpose SoC, but it also includes additional hardware and software programmable engines. One of the engines that we have is called AI engine, Adaptable Intelligence Engine, which basically helps in improving the performance and simplify the overall deployment process that is involved in this kind of a complex SoC. Along with this innovation in the hardware, we have kept on innovating in the software to keep up with the speed of the hardware. Several of you probably have used ISE Designs Suite. ISE was our the tool, the design entry tool till the 7 series of FPGA. Since we introduced the 7 series, or what we also call as our 28nm family, we started with a newly designed IDE called Vivado, and attached to that, we also brought in several programmability tools like SDX, which included embedded tool called SDSoC. We had SD Axle and SDNet at that point, and along with that, we also introduced HLX, which is the high-level synthesis engine to enable C, C++, OpenCL design entries into the FPGA. Last year, we brought in Vitis. Vitis is a unified software platform which encompasses all the previous tools, but also a lot more, including one of our very famous AI toolkit, what we call as Vitis AI. So all these are now integrated into a single unified software platform called Vitis. Can you go to the next slide? So in our latest family of products, which we call a 16nm, which is the UltraScale Plus Fabric family, we have all these different products that are mentioned here. On the top, what you see are the FPGA only devices. We have the low end, what we call as Artix UltraScale Plus, and the mid end, which is Kintex UltraScale Plus, and the high end is Vertex UltraScale Plus. And on the SoCs, as you saw from Tawfiq's slides, we have Zynq MPSoCs in different flavors. Basically, we have the CG devices, which is dual core. EG, which is quad core, and then EV, which is the quad core plus video codec engine built in to the device. So this gives the scalability from very low end and very cost sensitive platform from RTX UltraScale Plus all the way till the highest end devices which require extremely high end complex processing. Next slide, please. So when you look at the ISM or industrial, scientific, medical, which also includes vision, healthcare, and sciences that we have, these are some of the market trends that Xilinx looks up to when we are developing our products and solutions. So our innovations are typically intended to meet these trends. For example, when you look at the connected factories or connected IT and OT, that operation technology convergence that is happening right now, we have developed several products and IPs related to these platforms. Similarly, when you look at smart city or machine learning for cameras or predictive maintenance, we have several machine learning tools, IP, and we are building now ecosystem around it to enable this market trend. So for us, some of these market trends are extremely important, and Xilinx is heavily focused in developing products, IP, and ecosystem around these trends. Next slide. All right. When you look at the intelligent factories, here are some of the most common industrial IoT and vision applications that you typically see where Xilinx is predominantly present. We also have many other products around this, but these are some of the very well-known products where Xilinx is heavily used today in the industry, right? And some of these, as you probably can see, definitely needs the solutions that are presented from iWave and Disti. For example, the operator panels where HMI is a very good fit, and even other intelligent platforms and grid solutions where HMI is definitely a fair fit to have. In the next slide, you will also see on the medical field where there are several applications where Xilinx has been used. Especially in the medical field, HMI becomes extremely critical. We have seen several of our customers who look up to the HMI UI and HMI robustness in the medical field, especially ECG, defibrillator, patient monitoring system. Some of these applications is where we see the solutions that is shown by Disti extremely relevant. Next slide, please. So when you look at Xilinx, industrial customers are extremely important for Xilinx. Typically, Xilinx used to have a very steady growth in the past. When you look all the way at the chart that you see there is Xilinx revenue in the industrial domain. It was flattish from, let's say, 2009 till 2013-14 time, which was pretty much dwarfed by the introduction of Zynq family of products. So as you can see from 2016 onwards, once we brought in the SoC family, which integrated several functions, there was a huge adoption in the market, especially in the industrial market of this device. Even though the device itself was introduced in 2012, industrial designs typically take a few years to ramp up to production. Currently, we are seeing heavy adoption of Zynq and Zynq MPSoC family in the industrial assets. The primary reason for this is the integration of several functions and components that typically solve an industrial problem, which is highlighted on the right side. As you can see, all these different functions are integrated in a single chip, which enables this kind of a adoption in the industrial market. Next slide, please. Okay, one important thing when you look at industrial market is also availability and longevity of the device that we provide. Xilinx typically provides 15 years of longevity for any device. But in the industrial design case, it does take time to ramp up. We do understand that it's anywhere between 3 to 6 years time before you complete the design, get the mandated certification and regulatory process, and then enter the market. To meet that, we have several products which are, which has even crossed 20 years of life cycle. And if you go back in time, I don't know, some of you might have already used certain devices from Xilinx. We even have cases where we have supported more than 25 years of life for certain products. So that basically shows the commitment of Xilinx to this market, because this market sometimes is slow moving and also takes a lot of time to get into full production. And it does require extended temperature and harsh environment support in some of the applications. So we do have the same die which supports industrial, medical, aviation, automotive applications. So this gives that robustness of the device to meet different harsh environments. We have several guidelines within our quality teams to meet to support the high reliability requirements and safety critical applications. Xilinx does have functional safety certifications for its tools. Along with that, we do provide a very strong traceability support with our 2D barcode support on top of the chip, which also helps in ensuring the anti-counterfeiting measures. Counterfeit of devices is a big issue, especially in the current environment. So Xilinx is very focused on ensuring that the devices that are used in the market is genuine and comes from Xilinx. Along with it, it's important to note that 40% of Xilinx customers are from industrial, vision and healthcare sciences domain, which is a large list of customers. So it also means that the industrial customer base commands a lot of voice within the company within our company to ensure the right functions and right blocks are selected for the roadmap device. Next slide, please. Okay, I just want to take a minute to talk about the functional safety. Some of you might be working in this domain. Xilinx does support functional safety through different mechanisms. So the importance of functional safety, what we provide is, because there is so much integration that is already there in the device, because of fewer components, it reduces the risk and reduces the system cost. It also reduces the obsolescence, because instead of using 3 chips, you probably are using 1 chip now, which is done in the same device. And we do provide isolation flow for the device to ensure that some parts of the device is completely isolated and it is not affected by rest of the device, what is happening with the rest of the device. We do have a lot of documentation support for the functional safety certification. It is available on our website, Xilinx.com. We'll be more than happy to share with you what are the offerings from Xilinx on the functional safety. Please feel free to reach out to us. What is also important to note is Xilinx tools, Vivado and ISC are functional safety certified for IEC 61508 and ISO 26262 on the tool side. And on the device performance, we do have a soft processor called Microblaze. So the Microblaze GNU compiler toolchain itself is certified for the SLD certification under the ISO 26262. So we take functional safety very seriously, and we do have a lot of support that is offered from Xilinx for the functional safety, both for the SIL 3 and the SIL 4 standard. Next few slides, I just have, you can probably run through it quickly. I do have few success stories of Xilinx where Xilinx has been used in the industrial domain. The one that you're seeing currently is from Siemens for a renewable energy, a wind turbine controller system. If you can go to the next slide, we have Olympus, which is a medical application. It's an endoscopy application where Xilinx was used especially for the video performance that we provide and the low latency that we have on our devices. The next slide, you will see a GE intelligent platform control system, where also HMI plays a good role. Especially here, the point I want to highlight is the IP from Xilinx called TSN, Time Sensitive Network, which was dedicatedly developed for this type of application, which is being used by GE extensively in their platforms. Next slide, you can actually see a quote from Sony, which uses Xilinx for their machine vision application. They have had a very strong adoption of Xilinx in their machine vision applications, and they are one of our close partner, and we are very happy to engage with them and work together on their products. In the next slide, I just want to take a minute to also give you news that Xilinx is now acquired by AMD. We are in the final stages of the regulatory approvals, and it is expected to be a combined entity under AMD. And this gives a lot more leverage for Xilinx, being the fabless company, to ensure that we have more capacity from the fabs and also more innovation because of the R&D budget that is allocated for this. And what it also means, we can see in the next slide, is outside the Xilinx FPGAs, now we also will be, post acquisition, post regulatory approvals, this will be the combined, product portfolio that is already made public by the AMD in their investor slide deck, which includes Ryzen, Radeon, EPYC, and several of those processors, along with the FPGA and the SoC family from Xilinx. So there is a combined strong portfolio that will be available from Xilinx and AMD post acquisition completion. Please do look forward to it, and if you are currently engaged with AMD, please do continue to stay engaged with them. We will probably become a combined entity very soon. With that, I finish my slide deck. I do see one or two questions here, which I know we are just completed our time, but I would like to answer. Andrea, is there Xilinx versions for prototyping? Yes, we do. Prototyping and emulation and prototyping is a large part of our business. So we have several platforms and devices that are available for prototyping application. Please do reach out to us, and we can have a more detailed discussion on this. Thank you. Ruby, I'll hand it over to you. That was my last slide. Appreciate the patience from everyone to wait for me while I get my microphone corrected. Thanks. Ruby, are you there?
Rohit, you can conclude.
Yeah, can you all hear me? I would like to just extend a vote of thanks to everybody who attended this event. I appreciate all the people from different time zones joining this event. Thank you so much for joining our event, and hope you got some information about Xilinx, iWave, and DiSTI Corporation, about the solutions that we do offer. And what would be really interesting for us is that if you reach out to us on the email IDs that are provided in the beginning, we will be more than happy to guide you through and provide you more information related to your requirements. Right. With that, I would like to conclude this session. And once again, I would like to thank you all for taking time to join this session.
Yeah, thank you very much, everybody.